In this video, I'll be going over number 4, parts A through D of Test 6 review for standard class on the exponential and log functions and equations test. For number 4, if you would look at 4 and 1 over 32, they are not the same base, and your job is to create the same base. So if you look at 4 and 32, you should recognize them as like 2 to a power and 2 to a power. So that's the first thing we want to do, is rewrite these with 2 to a power. So 4 is 2 squared to the negative 3x, which would give us 2 to the negative 6x. On this side, the first thing we want to do is recognize that if you have 1 over a number, you should write it as 32 to the negative 1. And that would give us 32, remember, a power to a power you multiply, so 32 to the negative x plus 4. Since we still don't have 2 on the right side, we want to rewrite 32 as 2 to the 5th power. And then we want to, again, power to a power multiply. So we'll have 2 to the negative 6x equals 2 to the negative 5x plus 20. Now that we do have like bases, we can set those equal to one another. So we have negative 6x equals negative 5x plus 20. If we add 5x to both sides, we get negative x equals positive 20. Divide both sides by a negative 1, and x equals negative 20. So to check our answer, we type in negative 20 and we store it for x. Then we want to type in the left side of our equation, 4 to the negative 3x power, and the right side, 1 over 32 to the x minus 4 power, and these two numbers should match and be equivalent. So that tells us our answer is correct. For part B, we should recognize that we've got 7 on the left, and 49 can be rewritten as 7 squared, while this cube root of 7 can be written as 7 to the 1/3. So we're going to rewrite them with like bases first. We should also recognize that when multiplying like bases, you add their exponents. So if we add 2 1/3, that gives us 7/3 by multiplying and then adding the numerator. So we have 7 to the 2 minus x equals 7 to the 7/3 power. Now that our bases are alike, one single base on either side, we can set the exponents equal. So 2 minus x equals 7 over 3. Please be careful, this is a positive 2 minus x. So to get rid of the positive 2, we have to subtract 2. Don't make this complicated in your calculator. Just type in 7/3 minus 2. And if you get a decimal map, enter, enter. So that would be negative x equals positive 1/3. Divide both sides by a negative, so x would equal negative 1/3. Let's go ahead and type that in our calculator and store it. So negative 1 over 3, store as x, enter. And we want to type this in, 7 to the 2 minus x power. And see if that's equivalent to 49 times the cube root. Remember, to go to cube root, we have to type in math 4 and then our 7. Because these are equivalent, that tells us our answer of negative 1/3 is correct. For part C, notice our base is 11 and there are no exponents on the right. We cannot make the left and the right side have the same exponents. That means our job this time is going to have to be to use log to solve for m. In this exponential equation, when your variable is in the exponent, it's an exponential equation. And remember that since logs and exponentials are inverses of one another, we can use logs and their properties to solve for our variable. So your first job is to get the base and the power by itself. This term here is subtracted by 9, so we want to first add 9 to both sides. Negative 5 plus 9 is positive 4. Now this is the part where we go, well, we can't make them have like bases. So we put log in front on both sides. And we do that because it allows us to apply our property of logs, which says that a power can be rewritten as a product. So please put that quantity in parentheses. To solve this, there's going to be 3 steps. Remember, your job is to get m by itself, but we can't do anything to this quantity until we get rid of the log. So let's first divide by log of 11. Now that's gone. Our next step would be to add 6. Now that's gone. And then divide by 5. Now that's gone. Now when we type this in our calculator, we'll say m is approximately, and we want to make sure our calculator rounds to 4 numbers after the decimal. So we're changing that from float to 4, and we're going to type in, do these as individual steps. Log of 4 divided by log of 11, hit enter, then add your 6, hit enter, then divide by 5, hit enter. So our answer is 1.3156. So let's check our answer by storing that as our x. And then we want to go in here and type this in. 11 to the 5x minus 6. Oops, typed that wrong. 11 to the 5x minus 6. Then come down and subtract 9. If our answer is correct, it will equal negative 5. And it does. That's negative 5. On D, notice it has e in it. When we have exponential equations with e in it, we need to use natural log. So to get e by itself, that's our job, get our base by itself. We're first going to have to subtract 7 like we would any other equation. I'm going to bring down negative 8 times e to the 2 minus 3x. Negative 80 minus 7 is negative 87. Then I'm going to divide both sides by negative 8. Then I have e by itself. At this point, to get our exponent down, we have to remember that the natural log of e is equal to 1. So if I put natural log on both sides, we apply that property, and effectively that cancels because it just equals 1. So we have 2 minus 3x equals the natural log of 87/8. So I recommend doing this in 3 steps again in our calculator. So we would type in the natural log of 87/8, hit enter. Remember this is a positive 2 minus 3x, so we need to then subtract 2. And once we're done with that, we'll divide by a negative 3. So in our calculator, let's do all 3 of those steps individually. So natural log of 87 divided by 8, enter. Subtract 2, enter. And divide by negative 3, enter. So we get that x is approximately negative 0.1288. So I'm going to store that for x and check our answer. Negative 8. E to the x is second natural log. If you look at natural log, it says e to the x. Or you can just use the e above the divide key and then do your exponent. So negative 8 e to the 2 minus 3x. Bring it down and add 7. If our answer is right, it'll equal negative 80. And it does. All right. So there are all of your answers for part 4.